Welcome, everybody, to the Exploring 2025 Trends Strategies for the Future webinar here for the APAC region. My name is Kyle Oberholtzer. I've been a engineer, transformation consultant, a couple different roles at Tulip for about the past 5-6 or so years, based in Boston at our headquarters. I did recently move over here to Singapore to join our Singaporean office here as we grow in the APAC region. So today, we want to talk about a couple things about the APAC region, including China and Japan, how we're seeing manufacturing trends develop for this region, and then some things that we can do to address these developing trends, right? So everything that we're going to talk about here is kind of large scale for the manufacturing sector. So to get started, we want to start by talking about kind of the global outlook of trends in 2025 that we see going for the manufacturing sector, right? So this is across things that we see in North and South America and Latin America, things that we see in the EU, the Middle East, as well as in Asia, Asia Pacific, Southeast Asia, Japan, China, and Korea. So there's four main kind of trends that we see growing throughout global operations and global manufacturing. And these are going to kind of have a common theme that we're going to see throughout the webinar. So this is mostly all themes about global manufacturing and global transformation. So we expect that throughout 25, we're going to see trends continue that we've seen later or earlier, right? So this is going to be adopting continuous transformation and composable platform kind of structure in manufacturing systems. So the result is that these systems for manufacturers are going to become large format platforms that can support a variety of tasks and use cases rather than the point solutions that we've seen in the past. Of course, AI is going to be a trend that continues to develop, what with things like DeepSeek coming out recently, OpenAI having a new model, but we'll address how this is a little nuanced and shouldn't really be considered as a single transformative trend in itself. So the first thing to remember is that the current state that we've had in the past globally is point solutions, right? We've had single solutions for single use cases or ideas. This is a kind of legacy approach based on a lot of, legacy systems and restrictions, but this will likely become obsolete in the near future. So we know that as we see manufacturing developing in 2025, we see an increasing trend towards things like platforms, right? Instead of a single system, we have an open composable platform, an open ecosystem of integrations and stuff like this. Now, the reason this is happening, and the reason it's happening now, is that we see a lot of systems that are being built for manufacturing being easier to use. So if we think about how systems have been deployed before versus now, right? So manufacturing systems, like a lot of other systems, you call it operational or business or what have you, were built with this waterfall method, right? You do the first thing of your design, then you build, then you iterate, then you deploy. This results in a large kind of step function change of deployment. You have everything one day, then you shut down, and you have everything different the next day. This structure is very rigid. It tends to cause a long amount of time between the changes that you want to have happen in your operation to make it improve, but it's very standard, right? It's very structured, it's very organized, and it depends on specific key stakeholders who need to be able to participate at specific stages. We have software engineers who can only develop the software. So of course we need a develop phase where we're doing nothing else. We have business leaders who can put inputs in only during the design phase because they can't be involved in the other phases for the sake of continuity. Now, as we go more towards this software method, right? So we have things like composability, you have things like cloud structure. We have started to see manufacturing systems follow the trends that we've seen for other software systems, right? So this is moving to an agile method where development and iteration and improvement are cyclical, right? Instead of spending, X amount of months to do one single project that has its own definitions, that is rigid because each person needs to operate in their step, We instead see people now going to an agile model, like what we've built out or what has been built out for software, where we say, okay, because we can change things faster, we can deploy new versions and new experiences quicker. We can analyze the effect of these versions and experiences, and we can say, oh, well, this needs to be improved, this needs to be changed. Then we can go back and repeat this process. We're seeing a development of software systems or of manufacturing systems that closely mirrors what we've seen in software systems in the past. And to kind of illustrate what that means, right? So if we started a construction project or a manufacturing systems project maybe 10 years ago, planned it out in a Microsoft project for my Windows XP machine, then it's a big waterfall chart that will push into a big Gantt chart for my timeline. And I have a deliberate, this takes this amount of time, this takes that amount of time. I don't get full value from my project until the end when it's running, right? Again, there's benefits here, but the disadvantage is your speed to deployment. Because we're now seeing systems be built up with agile methods, things like building with a Jira-based method instead of a Gantt or waterfall-based method, the result is systems that are more iterative and more modular, right? So even in the middle, in the past couple of years, we've had things like modules where you buy the module for this and that, but those are still point solutions, parts of a whole. Instead, now, because we have software development kind of methodologies and ease to deploy, we see a lot of these systems becoming more composable. Now, composability is a very important point here. The manufacturing systems that we're seeing built across the world are sums of parts rather than one single point solution or one single use case. A lot of times, just because I work in mostly a operations-focused set of fields, these are human use apps, right? So we've seen the application and uptake of apps to be hugely impactful across the global deployment field, right? Gartner says that by 2025, at least 25% of manufacturing applications are going to be using this composable technology architecture. Composable technology architecture meaning an architecture built up of multiple small apps or multiple small pieces. Now, this is a change, right? This is improving, but this is because of this speed to deployment and speed of iteration that we're seeing throughout the tools that we're using. Now, part of that speed of iteration that I'm talking about is some of the integrations that these tools can work with. And of course, AI is one of these tools. So when we talk about AI, of course, this has been a massive development in the past, call it 2 years, right? And continuously, we're seeing better and better versions, better models, better agents able to do better stuff. That being said, we must always remember that AI is not a panacea, right? I can't just do AI and solve all of my problems in the same way that 3 years ago, I couldn't do vision and solve all my problems, or 10 years ago, I couldn't do robotics and solve all my problems, or 30 years ago, I couldn't just do assembly lines and solve my problems, right? So these things are tools, pieces of the whole, but they're not the solution in itself. So for AI, we're definitely seeing a trend continuing to rise of AI agents and AI systems being implemented, but that's a result of AI tools being useful, because absolutely they're useful, but B, systems being built that can integrate with these tools, right? So if you have this composable platform, one of the tools that you can plug into it is an AI agent, in the same way that you can plug in a CNC machine as a data source or a scheduler for order scheduling. So it's all about this composable approach that we're seeing grow in the manufacturing market and manufacturing sector as a result of these development methods. Now, to talk a little bit about the theory behind this, right? The manufacturing sector has been defined by a long time by the Purdue ISA 95 model, right? It's relatively strict prescriptive model of software systems that exist in manufacturing. We say that level 0 systems are production systems. The level 1 systems are production control. These are your PLCs. Level 2 is production monitoring. This is maybe your dashboard for the PLC. Level 3 is your MES. Level 4 is your business intelligence, and so on. This has been the model that we've been working for a while in manufacturing, right? And that makes sense because, again, for a long time in the field, these have been point solutions. It's been hard to develop these software and systems. It's been hard to deploy them. It's required specialized skills and experience. So making something like an extensible, composable platform wasn't really in the picture. As a result, we get this kind of diagram where we say, okay, each type of system is very strictly defined within my organization. And if I need something new, I have to say which of these levels it's going to go into. Modern systems, however, are changing this model. So we are now seeing that as we're having these faster to implement systems with more capabilities and features, systems are spanning these levels with increasing frequency. You may have an AI system that can do some low-level data analysis, but it can also then chart it on a graph. Or maybe you have an MES system that can do some production control and data capture, but it can also do scheduling and it can also do dashboarding, right? So no longer is it the best or most forward-thinking way to define software systems that we see with this rigid ISA 95 model. Instead, this pyramid has kind of evolved to represent still some domains in which certain systems work, but the systems that are implemented there are instead made because of the problem they're trying to solve. So if there's one thing to take out of this entire section of the presentation, it's that we're increasingly seeing software and systems be built for the problems they're trying to solve rather than the model they're trying to fit into. And I'll get more into that in a bit, but that's really the whole thesis of what we're seeing here, right? If you have a system that's easier to build, easier to maintain, faster to deploy, of course, you now have the freedom to say, I see a specific problem and I can go address that rather than I need to buy one thing that can maybe address 5 problems because that's the only way that I can implement a solution. This is a trend that we're seeing happen globally across all regions with varying amounts of maturity, but due to this prevalence of kind of easier to use, more composable software systems. Now, as that comes to APAC, there are a couple of different pieces that make APAC unique as a region in this wider outlook. So now focusing on APAC, right? So Asia Pacific is a very large region, very diverse, with very high net wealth, low net wealth, high cost of labor, low cost of labor, varying availability to things like internet and cable. And a lot of different regulations and regulatory bodies. So APAC is a very large kind of brush with which to paint these kinds of trends, but we do see some similarities in contrast to the majority of Europe and the majority of North America. The main one that we see first is the growth of cloud computing and cloud services, public cloud services in the APAC region, right? So in the past, 2 or 3 years, specifically Microsoft and AWS have put a lot of time and development into expanding their APAC cloud hosting market. And we know this because we see this, right half of the map here full, where 5 years ago there would have been 2 or 3 dots per provider in this region. So we're seeing a lot of investment in APAC, and we're also seeing a lot of response, right? We're seeing that APAC as a region is growing very rapidly in terms of uptake of internet and cloud services. Cisco said that by 2030, the cloud computing market is going to grow by about 24% over the past 6 years, right? And we know that this rate is the fastest of the large regions in the world, because if we take our numbers from 2018 to this projected 2023 number, or 2018 to recorded 2023, and then up to this projected 2026 number, we see that Asia Pacific outpaces our other global regions by 5 to 10% in terms of cloud user growth and internet user growth. Now, of course, this is things like social media and stuff as well, but this is analogous to things that are happening in the manufacturing sector, right? So over 2025 in APAC, we predict that cloud and edge computing are going to be increasingly used and increasingly popular throughout the manufacturing sector. And then this will bring along a lot of benefits, such as the Internet of Things kind of boom that we saw maybe 3 or 4 years ago, but now into the industrial half of it throughout the region. Now, why is APAC unique in this? We have cloud systems all over, right? We have cloud systems in the US, we have cloud systems in Europe. APAC is a bit unique in that cloud systems have been kind of mature and adopted by Europe and North America, the US specifically, for a little while now. And this is where, AWS was first starting cloud services. And there's a lot of lessons learned from that, right? So as we're seeing this rapid uptake, but also somewhat delayed initial start of the technology and of the architecture method, there's a lot of benefits that we can gain as an APAC-based manufacturing company based on these lessons that we've learned from other regions, right? And one of these is the difference between a cloud and an edge platform, right? So something that we've seen in a lot of North American and especially European sectors is that people are hesitant to large scale change, which absolutely makes sense, right? That totally makes sense. When cloud was first coming out, people didn't really know how it worked. People didn't really know how things would connect together. There weren't a lot of good platforms and usability and integrated systems out there. So we said, okay, let's maybe adopt a cloud system for one thing, or let's adopt a private cloud system, or let's get mostly an edge system, but you're going to buy an edge system and I'm going to buy a cloud system, and we're not going to really talk to each other, right? And the result of all of this is tech debt, right? So we see that a lot of customers now, if people come to us and we're working on their digital transformation journey, it's very not uncommon for them to say, yeah, we have some cloud systems, but we don't really have a cloud transformation, like transformative solution, right? So because this is one of the industries that we see, or technologies that we see growing so fastly and so strongly in APAC, we think it's definitely something that we can latch onto. We being actual manufacturing production managers and executives, using the lessons we've learned from these other regions. So the first lesson that we absolutely want to make sure that we know is that there is a difference between the value of a cloud platform and an edge system. If I want to complete a digital transformation project for my organization, the reasons I'm going to the cloud should be because I want, interconnectability and visibility and data transparency. I want centralized governance and control across multiple regions and spaces and sites. I want, centralized development and deployment, but localized customization and utilization, right? These are benefits of a cloud platform, but you don't really get them if you only commit halfway, right? There's a reason we say digitization and digital transformation are different, because true digital transformation involves making cloud platform technology architectural, not just a feature of one software system. Now, that being said, there is still a lot to be said about edge systems. No one's ever going to say edge systems would go away completely. If you have something that needs to work with low latency or high speed or questionable connectivity or high data aggregation or high data storage volume, then edge systems are a perfect approach, right? It makes complete sense why your PLC is locally networked, but it just sends aggregate data to your cloud platform for reporting and analytics. But what's different here, and what we're seeing grow in the APAC market, which is great because this is people learning these lessons from other regions, is that these two systems have separate benefits and they're not a good replacement for each other, right? For example, I mentioned that data storage volume is a good benefit of an edge system, right? If you just have 3 big hard drives you can shove a ton of historian data into, that's great. You don't have to pay very much for it relatively to a cloud system. And we know this, right? We know that edge data capture for things like local historians and things is growing extremely fast, right? By 2025, we should be growing, about 75% of data should be probably created and processed locally. However, the caveat here that must be remembered is that this is local sensor data. So this is, 30 hertz, 100 hertz, 200 hertz, fast data being processed locally before being forwarded to somewhere like the cloud. So this is a great indicator, right? This means that people are not recognizing that there's a specific benefit of edge systems, here being local data capture and aggregation. But we see this happening throughout the APAC market right now, right? And we expect this to continue throughout 2025. Now, when talking about cloud systems, especially in life sciences, we have to talk about validation and regulation. So in APAC, we've started to see an adoption of the newer method of validation, that is validation 4.0, that we've seen in the EU and US regions. Now, this is lagging a bit behind, mostly due to completely understandable unfamiliarity with various regulatory bodies, and more regulatory bodies tend to be applicable in this region than others. In the US, you tend to only have to deal with the FDA, whereas here you tend to have to deal with the US and Japan and Britain and India and China all at once. But it means that when you're thinking about this digital transformation journey, you have to also be thinking about validation if you work in the life sciences. Validation 4.0 is this model that got put out recently by the ISPE, and it's supported by the PDA. But it again it echoes this agile approach that we saw with software development, right? So just in the same way that we saw new cloud technologies and composable systems starting to be adopted by the market and by the region because of a newer way of thinking about how we can develop safely while still managing risk. We see the same method being applied to validation, and that is moving from a specific IQ, OQ, PQ waterfall method to a more agile method where we have iterative risk management and process validation rather than specific system validation. I can go into more into this if people are interested. But just suffice to say, the move to cloud, when I say that, it should be a transformative project that is treated as architectural rather than simply as a solution. I absolutely recognize that this has additional pieces in life sciences that make it more kind of, sticky to work with, but validation 4.0 is this method that we've started seeing proliferate around the region as well. And through 2025, we expect to see this happen more, especially through places like China, where regulation tends to be really tight. So given all of these methods, these changes in our technology, changes in the way that we deploy technology, and changes in the way that we think about technology, we want to talk a little bit about what to do about navigating these latest shifts, right? So if I have, seen this webinar, I'm thinking about some problems that I have in my factories and problems that I have in my systems, and how I need to address this, then some of our recommendations based on these trends, you can see here. Right. So first is embracing this flexible and scalable technology stack. So the very important part about this is the stack, right? So if you only remember one word from this entire point, remember this is a technology stack, no longer just a solution, right? Because if we go back to here, remember that, modern systems, modern technologies are sums of multiple parts. We're no longer looking at a world where we have to buy single point solutions for single items. We can now say, okay, well, I have an issue, I buy a solution, or I make a solution, I can solve the issue. I keep going because I know that I'm building this in a composable, ecosystem-friendly way that things can start connecting and talking to each other. So when we are embracing this flexible stack, sure, we want it to be flexible. Sure, we want it to be scalable. We always want this. But we want to make sure that we're actually thinking about this as a technology stack, right? We're now thinking about architecture and systems. We're saying, okay, how am I doing my reporting? How am I standardizing my unified namespace? Do I need to start thinking about a data hub? Often, one part of this conversation in many regions tends to be, now I have to think about internet as a critical resource, like electricity. So in order to do that, do I need to start thinking about backup systems, secondary or tertiary solutions? Do I want to go with things like cellular networks, 5G, Starlink, all that kind of thing to make sure that I will continue to have coverage in the event of an outage, in the same way that I would make sure that I have coverage in the event of a power outage? So first recommendation, think about your digital transformation journey as the entire stack and not just one piece. Second part, right? Make sure that we invest in problem-driven solutions, right? So when we are wanting to say, okay, we have some issues, we want to fix things, Nobody says, I want to spend thousands of dollars of money just for fun, right? We don't say, you know what I really want to do today? I feel like beginning a 3-year scoping project where we're going to spend $5 million to do something. I don't know what we're going to do yet, but I think it's going to be fun to spend the money, right? We think of specific problems or issues that we want to address. So that should also drive how we evaluate solutions and how we look for things. If we think back about the ISA 95 pyramid, how this has changed, we don't have to think, we're not limited by thinking now about the level of solution we need, right? So there used to be a big limitation where if I say I know that I'm having loss on my line because I know that we are finding more defects, right? I then had to either hire a consultant or be informed on these systems enough to make the logical jump between I have this problem and therefore it is fit by a level 0 solution, and then go look for level 0 solutions, right? That's a lot of work to do, and it tends to be a very specialized bit of work. Now, with composable systems, composable architecture, these level spanning systems, I can instead think directly from I need to be categorizing my defects better. What kind of system will help me solve that, right? The what level is it on question is no longer that useful of a piece of information. So when talking about the systems that we're working with, right, and the systems that we're using, we always want to work from a problem-based approach rather than a assumptive model of I just need something that is level 1 and it will do what I want. Because the other benefit there is through recognizing value, right? So something that we've seen be kind of a difficult thing to start in the US and Europe regions, that is true in APAC, but not as much here as yet, is that people with very kind of legacy models of thinking with like the ISA model will have trouble quantifying the value they're getting, right? So we always want to quantify the value that we're getting, and we're seeing this happen increasingly in APAC with things like sensors and IoT. APAC's investing very heavily in interconnected systems and interconnected hardware. But if you have the data, great. You need to know that it's better than what the data was before. And if you have an interconnected system, this multi-level spanning system, then you can absolutely measure something, see that it needs to be improved, and then measure that improvement. So when we're thinking about our digital transformation journey, we need to be thinking about a problem-driven approach, and then we're finding solutions to fit that problem. And then we're also thinking about an ecosystem of tools, right? So this calls back to when we were talking about AI. So AI is a tool. It is a great tool, a very flexible, fantastic tool to do certain tasks. However, what we are seeing in some regions is difficulty with identifying how AI can actually be used, right? Certain industries like law and healthcare documentation and quality obviously are very great at it because things like image analysis and documentation searching are perfect for AI. But in certain regions throughout 2024, what we have seen is that there tends to be a impression a lot of times that AI will just fix everything. And like I mentioned before, we have to think back on when vision was going to fix everything, or when AMVs were going to fix everything, or when robot arms and assisted. Remember when the HoloLens was going to fix everything, right? These are simply tools that allow operators to do something faster, quicker, better, but they still need to be implemented, right? We still need a platform on which to connect all these pieces of our ecosystem in order to get value out of the thing. So in tandem with this trend we're seeing through APAC of starting to adopt more composable, more interconnected cloud-based systems with a robust edge component, things like a unified namespace or data hub, we are also seeing an increase in interconnectability and integratability with things like AI agents, vision agents, that kind of thing. an increasing number of software and systems are existing just as IP as a service, right? Integration platforms as a service. Things like Zapier or Boomi exist because they just connect stuff together. And this is a trend that we're seeing grow throughout markets. These platforms that allow for integration, but also newer technologies have the integration in their own package, right? So in all, supporting this ecosystem of multiple tools and multiple agents tends to be these modern systems that are built with integration in mind and built with an ecosystem of different tools and systems in mind, including AI. But selection and evaluation of these platforms, of these systems, always needs to be done in a problem-driven method instead of a kind of legacy hierarchical driven method, right? We always need to say, I want to solve problem with tool, or I want to solve problem. How does tool help me solve problem? Without getting in the middle with, oh, but what category is it? Or what level is it? And that kind of thing, right? Because that brings us way back to point solutions, which is not where we want to be. Finally, we want to recommend people in 2025 to consider this holistically. Now, this is a bigger point, right? So in APAC, we've definitely seen that cloud adoption is still growing, right? So cloud adoption, like we said before, is growing faster than any other region in the world. More people in APAC are adopting cloud systems, growing with cloud systems than anywhere else in the world. And we see more local support, we see more local investment, but if the result is manufacturers, is operators who invest in a single system, regardless of that system is hosted in the cloud or not, then it's still just going to be a point solution, right? If I have 5 different public cloud or 5 different private cloud options that I host on site, then they're not really going to integrate to each other. They're not going to talk to each other very well. Development is still going to need some specialized skills and equipment. And we're going to be back where we started, right? It's just going to be that I'm also now paying a cloud storage provider for some of my data. Instead, we should be thinking of this as a more holistic model, right? Going back to this chart, we want to be thinking about the result at the end here, right? So if I can draw, we want to be thinking about the result at the end here as a sum of solutions. Now, importantly, that does not mean we need to have this whole sum of the solutions in mind when we start, right? Because more modern systems are iteratable, are composable, because we can continue to identify new needs and new issues if things are built in a composable method, things are built with scalable tools and platforms, things are built on public cloud architecture that helps you scale across sites, then we can start by identifying problems, identifying more problems, and then either addressing existing problems or going to new ones. And then eventually we'll have this great model, this great system, right? But the core thing to remember here is that we are not buying a single point solution, turning around and leaving, right? We're thinking about digital transformation and digital journeys as a holistic transformation of the entire operation. This is architectural, not just a single piece. Make sure that you're not creating more tech debt instead of actually improving the architecture of your operation as a whole. So this is overall what we tend to see in APAC. This is overall kind of what we tend to see on a global scale. One thing that I'll note on here that we haven't seen as much is a uptake of kind of citizen development model, right? So one interesting difference between the trends in these regions is that we find that in Europe and in America, especially with things like trade schools, there is a huge upswell of people who are able to start building solutions for their problems, but from an operator level instead of from a management level, right? These more approachable composable systems might allow people to not be a software engineer, but still solve problems. In APAC, we see this as being a little bit different, right? So this trend tends to be more that the people making and choosing these solutions tend to be a little bit more of the manager profile, right? Of the IT manager profile. One thing that I would caution, seeing this trend throughout APAC, right? We see these cloud systems growing, but we don't see kind of democratization of these solutions as much as we do in other regions. Even if IT is involved in something like a digital transformation project, even if management is involved in a digital transformation project, this makes total sense. But it is critically important that the opinion and input of production staff and production managers are given as part of this digital transformation tools, right? One of the values of this whole newer kind of system is the fact that you can increase iteratively, right? You can say, I want to do something small that's going to give me value, and then keep going on top of that. That doesn't really happen unless you have a continuous feed of real input from where the value would be felt. And where the value is felt is in your operation. So one thing that I would recommend to production managers in this region, to IT managers in this region who might be thinking about a digital transformation or digital transformation project, is to make sure that the production staff and manufacturing staff are part of this conversation, right? Because they are going to be the ones that provide the best input as to what is going to produce the best value. And because these systems aren't as rigidly defined as they were before, that input is going to be absolutely critical to make sure that the result is more valuable than what you would have got if you bought a point solution, right? Which again, we have there's a lot of problems about buying a point solution anyway, but this, if not full democratization, this inclusion of a production management and production staff is critically important. And it is something that we don't see trending in APAC as much as we do in Europe. Now, on the contrary, in APAC, we do see general digitization growing a lot more, right? We see general digital transformation growing a lot more as a trend. People want to do larger digital transformation projects, and that is great, right? People are starting to think about these transformation projects as fully transformative and not just making paper on glass forms. But as a part of this, you always need to include the key stakeholders for the solution that is being built. And here, that key stakeholder is the operators and the production staff themselves. Another point that we see growing in APAC a little bit, to touch back on the life sciences part, because I did see a couple of questions came in before this meeting on how this is specifically impacted in, I think it was mentioned, pharma, is that validation is hard. Validation is very hard, and it does not become easier when you're trying to have a faster iterative cycle. The make or break point for a lot of these EBR and EDHR systems, we find through experience in Europe and the US, is the ability to adapt your validation strategy with your development strategy, right? So if you're saying, oh, we're developing an agile method, but we still have to validate in a waterfall method, then you're still going to be bottlenecked by that validation. One trend that we see growing in Europe a lot is that adoption of this validation 4.0 strategy, this Pharma 4.0 strategy, means that users are putting out new changes to validated systems in days and weeks instead of months and years. In APAC, we see this growing less, right? Because there are, new regulatory agencies. Things like the Japanese regulatory agency are notoriously stringent on their compliance regulations. So if you have something that works with the Japanese agency, great. Hope you don't need to change it. But adopting a validation strategy has to happen if you want to adopt your development strategy. Otherwise, you're still bottlenecking by months before you can make a new change. And the result is a digital system that hasn't really kept up with the promises of a fully digitally transformed solution. So as one trend we see growing less in APAC, this is more projected for, I've seen numbers for more like 2026. I would recommend that, quality engineers, quality control engineers, quality managers throughout the APAC region start reading up on Validation 4.0, ISPE's recent rules about it. ISPE also recently put out some guidance about AI in validated spaces, which is really great because AI can do great things for documentation heavy spaces like the pharmaceutical environment. But without adapting your validation strategy, you can't improve your development strategy. It's as simple as that, right? So validation in Europe, we see growing more. Definitely recommend growing this awareness throughout this region for later growth if you're in the life sciences industry. The last thing that I want to mention is that we're seeing a lot of changes in how people also acquire software and how people use software, right? So in all of these things that we've talked about how these systems are changing and how these systems are changing on a global scale and on an APAC scale, we're also seeing things change about how people consume these systems. Right? We know that now more than ever, people are more familiar with internet-connected devices and tablets and phones. We know that in APAC that's especially true. More than anywhere else, more people are becoming internet users, becoming familiar with electronics and electronic devices. So we know that this adoption rate is increasing, right? If I make a tool for my operators, getting them to actually be able to use it is happening faster and faster. But acquiring that system or making that system is also changing, right? So we're seeing a bit more of people seeking out their own solutions rather than saying, okay, give me the top 10 list of level 0 systems from Gartner or whoever, right? But that reflects this change of this ISA 95 model, right? If I'm instead going from a problem-driven approach, then the way that I seek out a new solution or the way that I seek out a new answer to my problem is going to be based on that problem instead of having it based on a list of everything that categorizes itself as an ISA 95 level 1 system. So as we go into 2025, begin to think more strongly about the issues that you're facing, how you know that you're facing them, right? Are you quantifying anything? Do you know that this is affecting your lead time or your downtime or your cycle time? How do you know or quantify the things that are impacting your operation? And then start to search for composable, extensible systems that would help support that, right? You never want to buy another point solution and be locked into exactly what that is using. You want to be able to set yourself up for success in the future by building this technology stack instead of an individual item, and also making sure that whatever stack you're building is a sum of problem-driven statements. I'm solving this problem, this problem, this problem, and whether those are connected externally or internally to AI agents, devices, vision systems, whatever, your resultant system will be more feature complete, more agile, more directly tailored for your operation. This is all the content that we have for today, talking about APAC manufacturing trends and trends globally throughout 2025. I appreciate your guys' time today. Thank you for coming in. I hope you learned something here. I've been Kyle Oberholtzer with Tulip, and thank you so much. It's been a great day.